And now for our last example regarding sensitivity analysis. Keep in mind that this is part of a playlist. There is an original video to refer to, solving a linear programming problem without any sensitivity analysis at first. So we're going to look at, again, how much can we change the right-hand side of a the right-hand side of the inequality for one of the constraints and still have our optimal solution be coming from the intersection of the same two constraints as before. Now we're going to apply that to the other constraint, and we're going to add to the discussion talking about something called shadow price. So now we're going to have the second constraint sliding around. All right. So here's my previous work of doing Gauss-Jordan elimination to find the quarter point. Now when I put in plus H, changing row 2 by multiplying everything in row 1 by -2, that's not going to change the numbers because we're going to have -2 times 360 is -720, added to 300 is still going to give us -420, and the H came from row 2, which was not multiplied by anything. But then when we multiply everything in our new row 2 by -1/7 to get yet another new row 2, -1/7 times -420 would give us +60. But now distribute that also to this, we're going to have -1/7 H. And so then when we multiply everything in that row 2 by -4 and add it to row 1, -4 times 60 times -4 times -1/7 H will give us +4/7 H. And that's going to be added to the 360. That'll still give us a constant of 120, but we also have +4/7 H that we did not have before. And so by sliding around the constant where we had 2x(1) plus x(2) less than or equal to 300 before, sliding that around, now the intersection of the two boundary lines is going to be at this point. And those have to both be non-negative again. So on the first one, I'm going to subtract 120. And then multiply both sides by 7/4. The only time that you might change the direction of something is if you multiply or divide by a negative. And so the subtracting did nothing to that. And what we're multiplying by is positive. So it goes into -120, -30 times. Multiply that by 7, we've got -210. On this one, oops, H there. I'm going to add 1/7 H to both sides. And multiply both sides by +7. In other words, this is the one other place where we can switch directions. Instead of reading that as 420 greater than or equal to H, we could write that as H less than or equal to 420. So H is trapped between negative 210 and 420. Therefore, 300 plus H add that to both. 300 plus negative 210 would be 90. And 300 plus 420 would be 730. And we're going to take a look at one more thing, the shadow price. So right now we know that 300 plus H is trapped between 90 and 730. Sorry, that looked wrong to me. 300 plus 420, 720. All right, so now let's take a look at shadow price. Okay, so this point is if we keep H between negative 210 and 420, in other words, the right-hand side of the second constraint between 90 and 720, then we're going to still have the optimal solution created at the intersection of this and the boundary line that we get from the first constraint, x sub 1 plus 4x sub 2 equaling 360. And what we were supposed to maximize was z equal to 10x sub 1 plus 15x sub 2. The shadow price, if I remember correctly, is simply what would happen if H is 1. And what's that going to do to the objective function? So I plugged those coordinates into 10x sub 1 plus 15x sub 2, distributing the 10 here to get these two terms, and distributing the 15 here to get these two terms. I've combined like terms. And originally, as you'll see in the first video on this playlist, the 2100 was our original optimal value of the objective function. That was the maximum value. So we have, as H varies between 90 and 720, the effect of what that's going to do to the objective function is going to change it by 25/7 times H. And unit price, sorry, the shadow price is when H is 1. So 25/7 times 1, and doing that division, because we're talking about money, rounded to the nearest hundredth, 25/7. Let's check this here. 25 divided by 7. Yep, round that, $3.57 when H is 1. All right, that's all I've got for sensitivity analysis for now. See you in the next one. Stay safe and healthy.